Hi everyone, I wanted to provide a second piecewise function example for you to look at. This one is a little bit more challenging. As you can see in the problem that I have here, I have it broken into 3 pieces. So what I would encourage you to do, if you don't have it in front of you, would be to pause the video and grab some either graph paper or just scratch paper and take this journey with me, everyone. So what I want us to do first is focus on the first piece. Usually piecewise functions can be overwhelming because you see multiple pieces and your eye doesn't really know where to go. So what I tend to do, like in this example, is I broke them down into 3 different colors. So you could always like break out some highlighters if you're taking a test or you're doing homework or anything like that. So I'm going to focus on the first piece here. And what I want to note is that I want to note the domains. So the first piece has a domain where x has to be less than or equal to a -2. So basically where, again, I'm putting this dotted line in more as a visual for the lesson. You wouldn't necessarily actually put these in your actual work. But I'm going to draw the line down at -2 because what we're saying here is that -3, that function of -3, can only exist in this area that I'm kind of underlining or kind of showing you, okay? So if I look at the second piece, x minus 1, it's going to exist between -2 and 2. So I'm going to go ahead and draw that other boundary in. So my middle piece should only exist between these 2 lines. And then finally, my last piece is going to exist when x is at 2 or bigger than 2. Okay? So let's go ahead and take a look at the first piece. Now, what I want you to note here is if we were just to look at this piece, we're saying f of x is equal to -3. What kind of function is this? Refer to your toolkit, pause the video, and go do it. I'm assuming you're back now after going through your packet. This is what is known as a constant function. Okay, so remember that if you kind of need to justify, remember we're saying that no matter what input values I put in, I already know what my output will be. So I'm told that I have to pick values that are -2 or smaller because of the domain that is provided for us here. So I'm just going to work with like -5, -3, and we'll go all the way up to -2 because it is, after all, included. So basically, I'm told it doesn't matter what x value you're putting in from your domain, your output has to be -3. Don't argue with me. Must be -3. Constant functions can be quite the diva in a sense. So I'm going to go ahead and plot these in. So let's see here. -5 and then to -3. I have -3, -3. And then, oops, I am not plotting correctly. Sorry about that. So -5, -3. -3, -3. And then before I put it down, will I have an open or a closed dot? This is going to be very Blue's Clues, Sesame Street, whatnot. Correct. You should have a closed dot because the domain has a less than or equal to sign. We'll go ahead and we'll connect these points. Don't forget to put an arrow at the end of that drawing because you do want to indicate that the line is going to continue on to the left for infinity. Okay, so now let's move on to our second piece. And again, if we take a look at this, let's just say that this is g of x. It really doesn't matter what letter you're using for the function. It's completely arbitrary. That's why I'm kind of doing it to get you comfortable with it. But g of x is going to be equal to x minus 1. What kind of function is this? What kind of shape should you see if you were to graph this? And hopefully you're going to say, hey, it's a linear. And I would say, hey, you're right. So at this point, since it's a linear, you can kind of take your foot off the gas in the sense of finding points. You really only need 2 because 2 points can be connected by a straight line. And if you know that that's what the shape is, then by all means, just do 2 points. In this case, since your linear function is wedged between 2 values, I would definitely pick -2 and 2, so you know the extremes. If you want, put 0 in there or something like that to make you feel better, right? So if we put, I put F when I should be putting G. If I do G of -2, then we have -2 minus 1. So that gives me -3. G of 0 is always a pleasure to work with. So 0 minus 1, -1. And G of +2 would give me +2 minus 1, or 1. Okay, so here are all my coordinate points. So I'm going to go ahead and plot those. So we have one at -2, -3. So we also notice that we have that from the previous one. So what I'm going to kind of do is, technically, we would have an open circle for our second piece because notice it does not have an equal sign. So I'm just going to do this little like halo just to indicate that in this particular piecewise, they connect. As you have seen from the previous video, they don't always connect. Then I have 0, -1. And then since the other equality at 2 is a less than or equal to, what kind of dot will I be using? Correct, it should be a closed. So we would be at 2, 1. And lo and behold, we get, sorry for my imperfection there, but we do get a straight line. Squint and tilt your head to the right and you'll believe me a little bit more, I would imagine. Finally, let's go ahead and take a look at the last one. Let's just call this one h of x is equal to 0. And hopefully you should be kind of thinking, hey, this looks very similar to the first piece. Notice that you don't have any x on the right-hand side. This is a constant function. So again, if you need to make the table of values, go for it, just to help keep yourself organized and on track. But we know that we have to work with values that are greater than 2. But again, I'm going to start at 2 just for good measure. So we'll say, let's just do 2, 3, and 4. I'm feeling kind of lazy in terms of being creative here. So any input, I can pick any input that I want, but since it's a constant function, it's saying you must make it 0. Okay. So finally, I can go ahead and plot these. So I have a point at 2, 0. And again, this one is going to be open. So here's an example, again, of where the pieces do not lock together, but they do, but notice that you do have an open circle from this previous one over here, and you have you have a closed circle from the previous piece here, and an open one on the last one that we're looking at. So 3, 0, 4, 0, so it just so happens that this line is going to lay right on top of this part of the x-axis. Okay, and again, here is your piecewise function. Let's see here. Notice that all the x values are being used at some point in time. So here, I'm going to use a green line just to kind of trace my steps. So as I'm following this function along, notice I do connect here. So that's kind of nice. I'm coming up, and I do end at 2, and it's kind of like I have to hop down and then continue. But notice that if I were to make some modifications and kind of move that third blue piece up, they would interlock. You do want to make sure that you have a closed dot and an open dot in this situation. You would never want to have a closed dot here and a closed dot here. Then it would no longer be a function. Very much so the same argument if you had an open dot and an open dot. They have to be able to lock or connect to each other, or at least appear like they can. I hope this explanation has helped. If you do have any other questions, please feel free to come forward, and feedback on the video would be greatly appreciated. Thanks.